Hello and welcome to another Paramics Discovery video tutorial. My name is Malcolm and thank you so much for joining me today to learn more about Paramics Discovery. This is the third in our series of advanced video tutorials which we've started this year, 2019, and will be continuing into next year as well as we go into various topics and aspects of Paramics Discovery in greater depth. Today's tutorial is about zone portals and I hope you find it useful and enjoyable. So as I said, this video tutorial is going to be all about zone portals. I'm going to use the model that you can see on the screen to demonstrate the various ways in which zone portals can work. Now you can see with the model on the screen that it's got 4 zones in it, one in the west, one at the north, one south and one in the east. And some of the zones are placed over links in a very typical way. As you can see, zone 1 is placed over link 8 to 19, and so all the traffic that's going to be leaving and arriving in zone 1 will be leaving on link 819 and arriving on link 19 to 8. So it's very straightforward in how that traffic demand is going to work at that zone. But we've got another example of a zone in here, zone 2, which is covering 2 links. So the first thing when we start to look at zone portals is understanding how zones work when they cover more than one link. Now what I'm going to do is click on this zone and go to Properties, and we can find out a little bit more about how traffic is going to be released and arrive at this zone. And that's because the default options on here are the release link choice being proportional to length and the available links being the area inside polygon. So the second one is reasonably obvious. The available links or the area inside polygon means that whatever links zone 2 is covering, those are the links that traffic is going to be released on. So if I moved zone 2 off link 15 to 17, you can see it's no longer highlighted, and now all the traffic would be released and arrive at link 510. And if I move it back, you can see that the links 15 to 17 are highlighted again. So the available links are the area inside the zone as defined here. Now the next aspect is the release link choice, and we can see that that is currently set to proportional to length, which is the default position. Now the way that I've coded the links in this model means that this link here is about 25 meters and this link over here is about 50 meters. So what we should expect for the traffic being released from zone 2 is that we get twice as much being released here as being released here. Okay, so I'm going to save this. In my Visualize tab, if I refresh that and I'll drop the speed a little bit so we can see the traffic and hit play, you can see traffic going into zone 2, and we should see some traffic coming out of zone 2 as well, so you can see that there from both of the different links. And what I've actually set up in this model, if I go to my Edit Demand tab, is 100 trips going from 2 to 1 and 100 trips going from 1 to 2 over 1 hour. So that's what we're seeing in the visualization. Now it's quite hard to tell just from visualizing how many trips are going in and out on these different links from zone 2. So what I'm going to do instead is simulate this model and collect statistics over the 1 hour and then see how many trips there have been released from each of those 2 links within the zone. So I've got my configuration set up. It's going to run for 1 hour. It's using my demand set 1. I'm just going to collect the database, and all I'm looking at is turn counts. So I'm going to look at the turns at the junctions, which is going to inform me of the amount of traffic leaving the zone from different links. So I'll hit the green button to simulate my run. This should be very quick because it's a very small model and it's completed already. So I'll click on the Analyze tab, and in the Analyze tab I'm going to create a new data plot. So go to Analyze and Data Plots and Add, and I want to look at the data, my turn count data. So So I go to turn counts, it automatically picks up the turn count data that I've collected, and if I zoom in on the junction, I can see the turn count data there. Let me just tidy the screen up a little bit here so we can see it more clearly. I think I will take my decimal place off, I don't think we need that, and just change the colour. Okay, so we can see that we've got 99 trips have made it into zone 2. Now they're all turning in here, which is interesting, and I'll come on to that in a moment. We've got 36 trips coming out at this location, and if I go down here, we've got 64 trips coming out of zone 2 at this location. So you can see here how the proportional to length works. We're getting 2/3 more trips coming out on the far side of zone 2 and 1/3 of the trips coming out here. And remembering back to the Edit Network tab, that's because this link is twice as long as this link. Now you might have also noticed that we've got 99, or essentially all of our trips going in at this location, and we don't have any trips turning left in here. And that's because as trips are sent from zone 1 to zone 2, they're looking for the cheapest route. So this proportional to length is only for trips that are being released at this point. It's not for trips that are arriving at that zone. The trips that are arriving at that zone will be looking for the cheapest route, and that cheapest route is always going to be going in here rather than going further along and in here. Okay, so we've looked at how proportional to length works as a release link choice, but what does it mean for cheapest route? So let's toggle that on. And this one might be self-explanatory to you. The cheapest route effectively means that when trips are going from zone 2 to zone 1 this time, they're going to be choosing the cheapest route to get there. And it's pretty obvious which route that is. It's going to be leaving on this link. But let's save that, and we'll go back to the Simulate tab, and we'll run this again. Okay, and that's run and completed. And then I'm going to go back to my Analyze tab and open up my data plots, which is here. And I'll just delete the one that's there and add a new one and have a look at the turn counts as a result. And what we can see this time is that we've got 100 trips turning left at this junction and 100 trips coming out turning right. So all the traffic is going in and out at this location, which, if I go back to the Edit Network tab, is exactly what I would expect if we've chosen the cheapest route and the area inside the polygon. Okay, so we've looked at the two methods for release link choice from the zone, and now it's time to look at user-defined portals as an option instead of area inside polygon. So I'm going to toggle that on, and that opens up a new part of the property grid and also brings some new aspects to the user interface over here. Now what it creates as a default is one portal. So whenever I'm using user-defined portals, I have to have a minimum of one. But I can add more portals to that very easily by clicking this Add button, and I can also take them away very easily as well by hitting that minus button. Now the useful thing about portals is I can connect portals with links, and I can have more control over how traffic is released from the zone and also arrives at the zone as a result. So the simplest example is probably to connect one portal with one in and out link. So if I click on portal 1 and then click on these two links, you can see that it draws a line and connects portal 1 to these links here, and then click on portal 2 and click on those two links, and portal 2 is connected to those. And then I would use a demand percentage to define the amount of traffic arriving and leaving from those particular links. So let's say I want, in this case, 75% of my traffic to be leaving portal 1 and arriving, and the remaining 25 portal 2. Now you can see when it doesn't sum to 100 you get this red box, and then as soon as I get a demand percentage total of 100%, it removes that red box showing me that I'm going to get full demand release. So that needs to add up to 100%. So now we should get 75% of all our traffic leaving and arriving here, and 25% leaving and arriving here. So let's save that and simulate and see if that's what we get. Okay, I'll go to my Analyze tab and my data plots again and create another data plot using my turn counts, and I'll just change my labels so I can see them nice and clearly. Okay, so zooming in now on this junction, I can see that I've got 78 trips turning in, 69 coming out, 20 going on, and at this junction then I've got 19 turning in and 31 coming out. So the numbers aren't exact, and there's a random element to how traffic is assigned to these portals, but in broad terms we're getting that percentage split between those two sets of links going in and out of zone 2. So you can see now how the demand percentage set using zone portals has a big influence on the traffic arriving and leaving a zone. But let's look again at the release link choice that we looked at for zone 2, because this also applies to zone portals as well. Now if I took zone portal 2 for example here and added some more links onto it, let's say the links down in this location, I'm now spreading this 25% from zone portal 2 over more than just these links here, but down here. And now the release link choice will come into play and have an impact on the traffic arriving in these two locations. Let's leave it as cheapest route for now and save that and simulate. Okay, and I'll go back to my Analyze tab, and just as before we'll create a data plot using our turn counts and setting the colors. Now if I have a look in this location, I can see that we're getting the 75-25% split roughly for traffic turning in and out of this part of zone 2, so that's what I would be expecting. And now we're going to look at what's happening further down. So what I'm seeing here is that I've still got traffic going in this location, but if I come down to this junction, and remember we applied the new portals down here, or zone portal 2 down here, I've got no traffic. And that's because we've got the cheapest route option selected here. So even though my zone portal 2 stretches down here, it's cheaper to get to zone 2 from zone 1 by coming along and turning left than it is by turning right in here. Now if I go back to proportional to length and save that and simulate again, and I'll open up my data plot and add another one. I can now see I've got some trips coming out from the zone portal 2, which is here. So I've got 10 trips as opposed to 21 trips coming out of here. But all of the trips going into the zone portal are still going in here. Okay, so with proportional to length selected, because it's a release link choice, I'm getting some traffic coming out of here, because that will be based on the length of this link proportional to this one. So the link is shorter, so I'm getting 10 trips as opposed to 21 out of here. But I'm still getting no traffic coming in, because in terms of the arrival, it's always choosing the cheapest route. So if we wanted to have some more control over how traffic is released and arrives in this location on these links, then the best way to do that is probably to create a third zone portal, as opposed to spread zone portal 2 over these two locations, because it's going to give us more control and we're not reliant upon the proportional to length or the cheapest route methods. So what I would do is select zone portal 2, click on these links to remove zone portal 2 from them, and then add a new zone portal called 3 and select those links again. Now when zone portals are created from a zone, the zone placement is irrelevant, so we can move that zone to any location that we choose, and you can see the portals moving with it. And then what I want to do is define my demand percentages to get the split that I'm looking for between zone portal 2 and 3. So let's say 15% are from 2 and then the remaining 10% from 3. And I'll save that, and again we'll simulate, overwrite the database, and we'll go back to our analysis, and I'll do another data plot using turn counts again and changing the colours again. And let's have a look this time at how the traffic is split. So again, we're getting broadly our 25% split at this point. Most of the traffic is still going in and out on this link. And then as I get down to here, we're getting a split, you can see, between traffic going in to the zone portal 2 up here and along to zone portal 3, and we can now see traffic going in and out of zone portal 3, which is located down here. Okay, so the demand percentage method using the zone portals effectively overrides whatever we've got chosen as the release link choice. So as long as we've got a portal associated with the links that we want to define, then you'll be able to have a reasonable amount of control and influence over how much traffic is released and arrives. Okay, so we've learned quite a lot about how zone portals work so far, and how the demand percentage can be used to control the release of traffic from a zone and the arrival at different locations within that zone. And the final thing I want to demonstrate today is that we can actually have more flexibility and more control over how traffic is released and how it arrives based on the zone portal structure. So in other words, we can associate a zone portal just with traffic being released or just with traffic arriving. It doesn't have to be associated with both. So I'm going to make a few changes to the model to demonstrate that. And the first thing I'm going to do is remove these links here from zone portal 3, just to simplify it. I'm going to add another zone portal, we'll call it zone portal 4. And I'm going to make some changes to portals 1 and 2 as well. So if I select zone portal 1 and click on this link here, what I'm effectively doing is saying that zone portal 1 is now only for arrival of vehicles on this link, so it's not influencing the release of vehicles. And I'm going to change that to zone portal 2. So zone portal 2 becomes the release of vehicles on this link. Zone portal 3 will then be the arrival of vehicles on here, and zone portal 4 the release of vehicles. So the reason that we might set it up like this is if we wanted a different proportion of traffic to arrive here as it's being released, and the same over here. So I need to get a balance struck between zone portals 1 and 3, because those are the two arrival links, and portals 2 and 4 as the two release links, but I also need to get the total to sum to 100. So let's say the arrival at zone portal 1 is 40%, and the arrival at zone portal 3 is 10%. And then I'll switch that round for the other two. So we'll say the release from zone portal 2 is 10, and the release from zone portal 4 is 40. Okay, so you can see those numbers up here. Now what that means is actually of all the traffic arriving at Zone 2, the traffic coming into Zone Portal 1 is actually going to be 80%, because the other traffic arriving at Zone Portal 3 here is 10% of a total of 50. Okay, so in actual fact we're getting 80% and 20% of all the traffic, and then the same applies for the traffic leaving. We're getting 10% here, but it's actually 20 and 40, which is actually 80 between 2 and 4 leaving. So there's a little bit of simple arithmetic to work out exactly what the percentages are leaving and arriving, because we still need it to total to 100, but it's not too difficult to work out. So I'm going to save that again and simulate for the final time, and go back to my Analyze tab, get my data plot up again, and we'll add our final data plot. And we'll see what the traffic looks like. Okay, so now we can see we've got 80 vehicles going in, so that's the 80% going in here on this link, but we've only got 25 coming out, so we're looking at the sort of 20% mark coming out, and we'll see the reverse down here where we've got 17 vehicles, so it's that 20% going in and the 80% coming out. So we can structure the zone portals in such a way, as we've done here, to be able to get a difference in the number of vehicles arriving or leaving from a particular set of links. So that concludes this video tutorial on zone portals, and we've covered a lot in terms of how traffic is released from zones and arrives at zones, and how zone portals can be very influential in being able to define that release and arrival of traffic on the network, particularly when you've got multiple access points onto the network. They're very useful to keep the zone numbers to a minimum, and therefore you can manage your traffic demand matrices, but still have that influence over how the traffic is released and how it arrives in different zones. So thank you so much for watching this advanced video tutorial. We'll have another one coming shortly, and we look forward to seeing you then. Bye for now.